Hello everyone, this is Shafiqul. Today I'm excited to present to you an overview of Caesar Cipher encoding method. The Caesar Cipher, named after Julius Caesar, who is rumored to have used it for secret communication, is one of the simplest and most widely known encryption techniques. It operates by shifting each letter of the plaintext by a fixed number of positions down the alphabet. For example, with a shift of 3, A would become Z and B would become E and so on. So let's look into the diagram. We can see A is shifted by 2 and becomes C, where A is the plaintext and C is the ciphertext. Same goes for D, which is shifted by 2 and become F. What makes the Caesar cipher so elegant is the simplicity. With just a simple parameter, the shift value, it can transfer plaintext into ciphertext in a matter of seconds. This makes it ideal for quick and easy encryption, easily in situations where security is not a top priority. Despite its vulnerabilities, the Caesar cipher remains a valuable educational tool and a stepping stone into the world of encryption. It serves as a foundation upon which more complex encryption methods are built, providing a solid introduction to the principle of encryption and decryption. In conclusion, while the Caesar cipher may not after the robust security of modern encryption algorithms, its historical significance and simplicity make it an invaluable part of encryption in cryptographic education. Thank you for hearing me. My next group mate will continue from after me.
Hello everyone, myself Harshada Kripal. Today I'm going to explain decoding method when the offset is unknown. The Caesar cipher is a symmetric encryption technique. It utilizes the same key for encryption of both the plain text and the decryption of the ciphertext. Decoding a message when the offset is unknown typically involves using statistical analysis and frequency analysis to determine the most likely offsets. To decrypt a message without knowing the offset, we will consider the following steps. First, we will look into a table uh, which shows a character frequency analysis. Let's say letter R holds frequency 102, V holds 115, exclamation marks holds 275 frequency, and ampersand holds 124 frequency. Let's get to the next table, which is English letters. The letter A holds 8.2 frequency, E holds 12.7 frequency, O holds 7.5% frequency, and T holds 9% frequency. However, we cannot boldly estimate that most frequently used English alphabets will be mapped by the most frequently used alphabets in the sample of ciphertext we are analyzing. This is because the ciphertext is too small of a sample to make a strong estimation. So, first, we will analyze the gaps between the high frequency letters in the frequency tables that is not sorted. The above screenshots, from the given screenshots, we can see that in English alphabets frequency table gap between A and E is 3, and in the ciphertext frequency table of our secret one text file, the gap between R and V is 3. From this, we can make a bold guess that R equal to A and E equal to V. Similarly, we'll go for exclamation mark and ampersand. Because the gap between O and T is 4. Similarly, in the ciphertext frequency table, the gap between exclamation mark and ampersand is 4. Then from this, we can write a script to check the difference between the ASCII value of the characters R and A, V and E, exclamation mark and O, and ampersand and T. This is how we will find the offset key. But we need to make sure the ASCII key value array or data structure that we are using to find the difference is functioning like a circular array or a list. Or we can use some adjustment as given in the below code to wrap around to start from beginning when the difference is greater than the last character value in the list. This code checks if a character's ASCII code falls within the printable ASCII range from space to tilt inclusively. If it does, it adds 17 to the ASCII code of each character. If resulting ASCII code exceeds 126, it wraps around to the start again from 32. This code essentially implements a Caesar cipher with a shift of 17, ensuring that only printable characters are modified. Using the offset and similar concept, we can decrypt the ciphertext. Thank you.
Hello everyone, this is Tiwari. Today we're going to discuss about encryption technique using Caesar Cipher. Caesar Cipher, named after Julius Caesar, who reportedly used it for confidential communication, is one of the simplest and one of the earliest encryption techniques used by human beings. It operates by shifting each letter in the plain text by a fixed number of positions. The fixed number of positions up or down on the alphabet test. Okay? And it is the fixed number of positions can also be called an offset. For instance, with an offset of 3, in the encryption of plain text A would become B in ciphertext, and B would become E, and so on and so forth. It is a very simple encryption technique. Let's see a an implementation of this encryption algorithm in Python. Here we're basically opening our plain text file which contains our plain text or the original message which we want to encrypt. And we're opening up a second file in the pen mode so that we can write our output of this encryption or our ciphertext on this file. And we're looping through each line in our plain text file on this line, and we're essentially looping through each character within that line. And we're creating an getting an ASCII value of the character, each character, and checking whether it lies between 32 and 126, which is the visible ASCII characters. And we're using offset of 17 and shifting the alphabets by 17 position. And we're getting the new ASCII code in this t underscore or variable. We're checking whether this ASCII code is greater than 126 or not, because it will not lie between, so it will not be a visible ASCII character. So we'll circle back to the list or table of visible ASCII character, and for accelerating back, we're subtracting 126 and adding 31 to the ASCII code. And when we get the ASCII code of the visible character, which is our encrypted ASCII code, we'll then again change this back to the character or an alphabet and write it to our secret text file, that is our output file. And if it is not the visible ASCII character, will simply write it to our output file. And after completing the operation, we close each of the file. So let's simply run this program and check for the output. This is our plain text. So run the program. A secret file is created, and this is the output. In theory, you can basically use this to transfer our message to via unsafe medium to our intended receiver. But in modern world, Caesar Cipher is highly susceptible to brute force attacks because it has very limited shifting alternatives to the characters. So modern day computers can easily decrypt it using brute force algorithm. Thank you.
Hello everyone, I'm Apil Parajuli, and today I'm going to talk about decryption process of Cipher. So decryption is a process of converting encrypted encoded information back to the plain text, original text, and it is also called decipher decode. So let's get into our code. So we can see that there's a file named secret1.txt where we have our encrypted file. So and after running this code, will a new file will be created named plain.txt where our file will be in. And for each character in the line, we check if it's a normal character like a number or a punctuation by looking at its ASCII code. And if it is ASCII code, we change it back to the original character by subtracting 17 from its ASCII code. And if the new code is below 32, which are like special characters like spaces, we wrap them around to the end of the range, which is 126, to get the original character. So let's run this code, and we can see that our new text file has been created named plain.txt, which says which says welcome to Simo. So it is the same the file. It is the file that has been decrypted. So in summary, to say conclude this video, so this code reads a secret message, figures out what the hidden letters really are, and writes a decoded message into a new file. So thank you.
Hi, I'm Sartaj, and I'm going to give a brief summary about what we learned from this assignment. So we first explored what Caesar Cipher encoding is, how it works, and then we saw the importance of the encryption key, which is same for both encoding the plain text and decoding the ciphertext. So that's why Caesar Cipher is a symmetric encryption technique. We saw that if we don't have the offset, how we can find it out using frequency tables and gap analysis. So we can find out the offset from that, and when we have the offset, we can just write simple scripts to go on to the decryption process. Later, we explain the encryption script and the decryption script, the changes that we made, and ended it up with what we learned from all that. Let's take a look at the encryption script that was provided. So the way it encrypted was it added the offset to the ASCII value of every character from every line. And for the characters, when adding the offset, it was going beyond 126. That was managed by subtracting 126 and adding 35, so that it was within the range of 32 to 126. So we use the same code for decryption, but made changes in these two segments where instead of adding the offset, we subtracted the offset. And we just sort of managed the fact that it doesn't go below 32 by wrapping it around the range of 32 to 126 again. And we actually use this little script to find out the frequency of all the characters in secret1.txt to demonstrate how we can find out offset, but here we already knew the offset. So when we run the decryption.py code, we get a plain text file. When we concatenate the plain1.txt file, we get the decrypted message. So from this assignment, we learned about basic cryptographic principles using Caesar Cipher encoding and decoding, and we learned the importance of key management. We also learned some practical aspects how to encrypt and decrypt messages. So thank you.